Alexandra. Right, excellent. So AppsFlyer and Alexandra. So maybe just introduce yourself then and tell us a bit about what you do.
Yes. Good evening, everyone. My name is Alexandra. I am a business data engineering team lead at AppsFlyer. So AppsFlyer is a mobile attribution and marketing analytics platform that provides basically full analytics picture for marketers out there in the world for all the mobile campaigns and how to manage campaigns. So basically we manage everything from clicks to impressions to in-app events. Since our SDK is implemented in an app, we start to collect all the information, all the impressions and clicks and events that coming from this app. And then we just can analyze and tell how many clicks and impressions came from which campaign and which one is better. So my team, we are responsible for providing an internal analytics, not for customer facing, but internal analytics. And basically our goal is to make all AppsFlyer data available and accessible for analytics, including not just customers' data, but also internal data, business data, billing data, and so on and so forth.
So that's very interesting. So it's a very different use case. Is this actually working, this thing? I'm not sure it's actually working. Is it working? I don't know. I've been using it. I'm not sure it's actually working.
Why is this too low?
Well, okay, right. So this is a very different use case to Aaron's, okay? Because Aaron's was about embedded analytics in a service. So yours is about providing analytics to your end users, okay? So again, question, what was the problem you're trying to solve, and where did Firebolt come into it really in this setup?
Yeah, so initially our data stack looks like we have also Kafka that collects all our events, different Kafka topics, and we store all our data. We have two data pipelines. One is a raw data, one is the aggregated data, also all for customer needs. And we store the aggregated data in S3 as a Parquet format. And initially when AppsFlyer started to grow and analyze the data for internal needs, we started to use Athena as our data warehouse to analyze data and run queries. But very, very quickly, we found ourselves waiting for 15 and 20 minutes for queries to come back because of the data amount. And I'm talking about now it's about 150 billion events on a daily basis, which is about 100 petabytes of data in S3 on a daily basis, which all of these need to be analyzed. And for example, for product needs, we ran some ad hoc queries that contains many analytical functions, window functions, and many, many complex queries that basically gave us a very, very poor performance in Athena. And along with all of that, join this, for example, Salesforce data and billing data and some pricing data become a very, very huge performance issue for us. So we've started to look for an internal data warehouse solution that will basically give us a better performance and value for money, because we've been analyzing many, many different products out there like Snowflake and Vertica and Redshift. And also, like in the previous use case, it was very, very expensive for us. And for internal analytics, you know, we all have a budget to use. So eventually we were looking for a better solution.
So you said Athena. So I guess that's because you've got lots and lots of granular data coming into kind of like S3 or something. I mean, Athena is pretty kind of one extreme, isn't it, in terms of performance and so on. But what was that? Paint a picture of I suppose, the volume of data and maybe the number of users you've got, and give us a sense of the scale of this, really. Yeah.
Yeah. So just to give you a bit of a scale. So we've started for about 4 analysts that running queries on top of Athena, and about 200 users. We use Looker, by the way, on top of Athena and on top of Firebolt. So we've started from 200 users, which was about a couple of dozens queries, concurrent queries. And it worked well, but very, very quickly we found ourselves with the hyper growth of AppsFlyer. During, I think, 2 years, we've got almost 1,000 Looker users.
Wow.
And dozens and hundreds of concurrent queries, complex concurrent queries. And because we use also some complex permission set in Looker, each of our users run a different query. It means we cannot even use the cache mechanism because we have many concurrent queries, which are completely different because of the permission set. So we found ourselves with many concurrent users and queries, and the performance was about, we've been waiting for queries in queue for 15, 20 minutes, and eventually query exhausted, query key, and so on and so forth.
Okay, so to the point earlier on about how does Firebolt work in terms of, is there a model in there and so on? I mean, maybe just walk us through the development process really. So do you, for example, use a tool like DBT to kind of build things like, tables in Firebolt, or do you use Looker's, derived table? I mean, talk us through the development process and where the Firebolt bit comes into it really.
Yeah, so let's start from the S3 as the data source. So we have all the data in Parquet file in S3 in a certain folder. On top of that, we've been using Athena. Now we've developed a process that migrates all of the tables in S3 to Firebolt and creates the necessary index and aggregate index and all the necessary data that we need. But all the modeling layer and all the business logics and everything is in Looker. And it was initially in Looker because of the LookML modeling layer, which was very quick and easy for us to create business logic. So we kept all of this in Looker, and we still keep it in Looker, which gave us the migration very easy. I mean, once the tables are in Firebolt, we just switch our dashboards in Looker to point to the model and the connection to Firebolt instead of Athena, and that's it. We've got seconds for the same dashboard that we've got 15 and 20 minutes before.
So to be clear, you're not pre-computing aggregates and so on. You're actually not pre-computing joins. You're actually doing everything on the fly.
On the fly, exactly. Everything on the fly.
Interesting. Okay.
Do some PDT, some cache mechanism, but as I've said before, because of the permissions, different permission set for different teams and access on the row level and column level, you basically cannot use the cache. So initially, it was just very easy for us because all the LookML and all the logic was already inside Looker, and because we've already built it during 2 years. But now, as we are, I think, 1.5, almost 2 years of implementing Firebolt, we also have many logics already implemented, and we've actually created some kind of semantic layer, we call it, which is also because AppsFlyer grew up, and there are many new departments joining the team, and you don't have one source of truth. So we've developed something that we call semantic layer, that we store the cross-company business KPIs. We have them inside the Firebolt model. And for the ad hoc queries and for some custom analytics for different departments, for example, CS and sales, they're using some different KPIs, but maybe for the finance team and for the cross-company owned business KPIs, we keep it in Firebolt. But this is something new that we already built on top of everything we've had.
So what kind of average query response time do you get really on this? So presumably people are using explorers and they're doing ad hoc analysis. So what can they expect their response time to be like, and how different is that compared to, say, Athena?
Comparing to Athena and also what we compared in POC in Snowflake and Vertica, it's seconds, and we've got milliseconds. There were dashboards and queries that we've got just milliseconds running instead of 10, 15 minutes.
Okay. And so you mentioned about indexes there. Okay. And so one of the features of Firebolt is one of the ways in which it gets performance is through sparse indexes and various mechanisms there. So how does that fit into your workflow, and what do they bring to it, and how do you keep those maintained maybe?
So initially, when we migrate or create a table on Firebolt, we create an initial index because all our analysts, they know initially what are the dimensions and measures that will be queried in ahead, so they know. And on top of that, we have about 70 analysts now at AppsFlyer that are divided to about 10 different teams, and each teams are correlated to a different business department, and they work on a specific department's needs and KPIs. So for most of the queries in dashboard, they know in ahead what are the measures and the aggregations and the dimensions that will be used. So we also defined on top of that aggregation indexes and join indexes because we know what are the queries that will be used in the Looker dashboards. For other use cases like product analytics, which are a bit more ad hoc, we just query in Firebolt, create the indexes that we need on the fly, and then we just drop it and move on.
And one last thing before we get to the questions. So you mentioned cost as well, right? So how does it work out cost-wise compared to, say, your previous solution?
So the previous solution in Athena, we've got as many resources as we could from AWS, and again, the performance against the cost was very, very high. When we evaluated other services like Snowflake and Vertica, the cost was like 5x than we've had with Firebolt.
Very good. So, questions?
Initially, you had data stored as Parquet files, and then you migrated over to Firebolt. Do you still store data as Parquet files?
Yes, because as we're internal business data engineering department, we have everything from the R&D, from the client side, as given, so we cannot change it. So they still use Kafka and S3 and Parquet. So we've developed our own sort of ETL process, just a Python framework that gets the Parquet file from S3 and migrate them to Firebolt. So we see whether it's a partitioned table, so we define it as a fact, and we use it incrementally. So every day we just get the new partitions to Firebolt. And if it's for example, Salesforce data, which is quite small comparing to the other data, we define it as a dimension tables, and we just drop and delete it on a daily basis. And everything is just wrapped up with a Python process, and they schedule the airflow. And
so to be clear on that, so do you leave it all in Parquet format, or do you load it into Firebolt's is it F3 format?
F3, yeah. Right, in Firebolt, it's F3 format.
Right. Okay. So
which is sorted, aggregated, and indexed, and everything.
And how much effort does that take, and time, and so on? Is that something that you can do fairly quickly, or is that a major part of the kind of the workflow? Really doing that?
It depends. So initially, as we were a very, very early adopter of Firebolt, we basically developed everything ourselves, and we did have challenges during the way. I'm not saying everything was smooth, but once you can define the schema of the table, it's just to create an external table and then to create an internal table, which is select table, insert into from select, and that's it. But when you want to do it for many, many tables and want to do it automated, and you want so the process know by themselves which is a fact or whether it is a dimension, is it incremental or not, does it have a partition, schema evolution, and etc. etc. It was quite challenging, but eventually we have data engineers. All our team are data engineers, and we use Spark and Python in every code as needed. So eventually we've developed a process. So the join index is, for example, when we've tried to join some Kafka topic, which is 4 billion rows, which even a small table in Salesforce, which is 2K table, it was very, very hard for the Presto behind the scenes to run this join. In Firebolt, we've been able to just create the join indexes, which will define the join between the tables, and not just sort the materialized views on one table, but for the aggregation of both tables joined together. So it gives us even more performance and even more speed.
So what's the penalty for not having indexes? How fast does it run without this? So if you missed an index, how fast does it run if that's the case?
Also, it depends. It very depends on the table, on the use case, on the query. It very depends. We've seen from milliseconds to minutes and from minutes to 10 minutes. So it very depends.
In implementing so many indexes and maintaining
A cost?
Yes.
No.
Well,
I mean, creating an index won't cost us anything. It's just how many queries you're running and what type of engine you define on top of this. That's it.
Well, what about your time, though? Your time and kind of the effort goes into it? Because, I mean, is it a big kind of like thing you have to think about, or is it?
Yes.
Yeah.
So this is a real job for analysts. So they need to know exactly what kind of dashboards and what kind of queries they are running. But this is exactly their job. This is exactly what are they doing. They are defining the queries and running it and creating the models in Looker. And what is also a big advantage in Looker, so after creating a model and you define, okay, I need to join this table and with this table. Once you just pick up the needed measure, the looker creates the query for you, and you can see exactly what will be joined and how, and then you can create an index based on this query in Fireball. Yes, this is a manual work, this is an effort, but hopefully it will be much more automated.
So there's no like credit cost for generating indexes in Fireball? Is it a free thing, or do you pay?
No, you don't pay anything for creating an index.
Well, I mean, the engine. So Fireball has a concept of engines, and the engine will be running at that point. So there'll be a cost for the engine running. So if you had to add an engine onto it to be able to process the indexes, but certainly there's no.
As long as the engine is on and running,
Yeah.
it doesn't matter how many
Yeah.
indexes or queries you're running. The storage you will end up, of course. So you have the storage that you pay for Fireball to ingest the data, but it's compressed. It's compressed. It's sorted. So it takes much less storage than initially in S3, and we've compared it. And of course, the engine that is the eventually it's in your AWS EC2 machine. So you define what type of ingest or analytics engine you choose. So we have two types of engine, one for ingest, which is more, I don't remember which one. One of them is more RAM-based, and the second one is more CPU-based. So you just ingest on one type of engine, and then you run your analytics on the second type of engine, and you can just shut down and turn off and turn on them however you need.
Is that what you meant? Is that what you're asking?
So it's more about so in Snowflake, directly in my experience, is if you implement an index or a cluster in the wrong way in Snowflake, it can cost you thousands and thousands of pounds.
Well, because it makes queries less efficient.
They've got auto clustering. So if we've got a lot of data coming through all the time. We implemented a cluster on a very big set of data. In the space of hours, it cost us like $20,000, and then just kept going. So I turned it off, and we think about how we did that. That's why I asked the question about index.
Yeah, but it's a completely different mechanism in Fireball. We've also did a POC with Snowflake, and we saw how much it will cost us. The estimation was very, very high. But in Fireball, it's a completely different pricing model that is also one of the reasons that we chose this vendor.
Interesting. Thank you.
Okay. So any other questions at all? Oh, yeah, the gentleman at the back had one as well afterwards. Yeah.
How is data modeling working for you? Is the modeling already defined by the Kafka topics that exist that go into Fireball, or are you using something like dbt on top of Fireball, or is it all living inside LookML? How is it working?
So for customer facing, we have Spark jobs that runs after the Kafka topics, that runs some aggregations and some logic, but this is not for internal analytics. This is for a customer side. For our internal analytics, most of that is in LookML. We have some internal ETL processes that also create some business logic, Python process, ETL, but most of it's in Looker because we work in a decentralized BI and analytics approach, meaning we are, as a business data engineering team, we're just providing the data to make it available and accessible, as I've said. But from now on, all analysts, and we have many of them, they're defining all the KPIs and all the logics inside Looker.
You talked a bit about that semantic layer being modeled in Fireball as opposed to being in LookML. Mm-hmm. Is that done on when it's coming from S3 on your ETL processes and in Python, rather than doing any modeling in the warehouse on top of Fireball?
We've defined it in our ETL process behind the scene. Yeah. As we grow up and we found ourselves using the same KPIs but calculated differently in the LookML, so we've decided to create a semantic layer, meaning to take out all the cross-company business KPIs that are needed to be calculated in a certain way, and there is like one source of truth for them. So we took them out from the LookML. We created a Python process that just calculates them, and then we ingest everything to Fireball. So analysts have a clean semantic layer, and everything else, which is more on demand, it's remaining Looker.
Follow on from that as well for me is did you find that Fireball favors maybe one big table or less joins, or were there ways in which you found that your data could be sort of like structured that would work better with Fireball really?
So because of the really huge amounts of data and many different topics and many different needs, we prefer to create materialized queries and materialized tables and have much more tables, smaller tables with less amounts of data. But for certain amounts of need, you can just pick the relevant table and join them together, rather than analyze huge amounts of data in one big fact table every time. So we've just divided it to small tables.
Okay, thank you very much.
Thank you very much.
Thank you.